When we gaze at the night sky and see the moon, it's hard not to feel the deep connection that binds its history to our own existence. The moon is not just a lifeless stone sphere orbiting in the cosmic void. It is our cosmic companion, a keeper of secrets that reveal the origin and evolution of Earth. Imagine an epic cosmic odyssey where our planet and its satellite play central roles in a grand play performed against the backdrop of stars. About 4.5 billion years ago, when the solar system was just beginning to take shape, Earth was a young and restless planet, engulfed in chaos and destruction. Space at that time was a wild and dangerous place, full of energies that are hard for us to even imagine today. Whenever I look at the moon, I picture that moment when a massive celestial body, roughly the size of present-day Mars, known as Theia, collided with Earth. Imagine the force of this collision. The energy released was so immense that part of the Earth was literally thrown into space. One of my colleagues once aptly remarked, "The moon is the mark of a cosmic slap that Earth received in its youth." This phrase, despite its playfulness, accurately conveys the scale of the catastrophe. The enormous debris, initially scattered chaotically, soon began to coalesce under the influence of gravity, forming what we now know as the moon. It was not just an act of destruction, but also of creation, as the force of gravity turned chaos into something ordered, creating the satellite that has since illuminated our nights. Imagine this ancient cataclysm, how the destructive force of the collision not only led to the birth of the moon, but also transformed Earth beyond recognition. This event influenced the internal structure of our planet, its atmosphere, and even its orbit. The moon became a sort of guardian, a companion that has since accompanied us throughout our history, affecting many processes on Earth. The birth of the moon is not just a scientific fact. It is a fascinating cosmic drama where chance and the force of gravity work together to create something as magnificent as the moon. It is a reminder of how order can emerge from chaos, how destruction can become the foundation for a new beginning. From the moment of its birth, the moon became a crucial player on the stage of Earth's life. Its gravitational influence initiated the complex dance of tides, the movements of the oceans that not only shaped the shores of our planet, but may have also played a role in the origin of life. In ancient myths and legends, the moon was often depicted as a mother, giving life. And there might be some truth to this. The tides caused by the moon's gravitational pull could have created the perfect conditions for mixing chemical elements and giving rise to the first living organisms. Imagine this. Vast masses of water, controlled by the moon, dancing on the surface of the Earth. This dance not only enriched the ancient oceans with the ingredients necessary for life, but also created conditions for their mixing, possibly contributing to the emergence of the first living cells. But the moon's influence extends far beyond the oceans. It also affects the Earth itself, gradually slowing its rotation, as if gently breaking the planet in this endless cosmic dance. Sometimes, when I look at old pendulum clocks, I imagine that the moon is like that pendulum, subtly slowing the passage of time. In the distant past, days on Earth were significantly shorter, but thanks to the moon, they gradually lengthened, as if someone was slowly winding down a giant celestial mechanism. But this is not the moon's only role. It acts as a stabilizer of Earth's axial tilt. Imagine trying to keep a globe steady as it constantly tilts one way or the other. Without the moon, our planet could experience similar tilting fluctuations, leading to extreme climate changes. I once read an ancient text describing cataclysms caused by sudden climate shifts. It was a myth, but it held a deep truth. Without the stabilizing influence of the moon, Earth could plunge into chaos where seasons change as unpredictably as weather in a stormy sea, turning the planet alternately into an icy desert and a burning inferno. The moon, like a cosmic gyroscope, keeps Earth in a stable position, creating the conditions for a stable climate that sustains life. Every time I see the moon rising, I feel gratitude to this celestial companion, which for billions of years has maintained order on our planet, making it habitable. When we look at the moon through a telescope, or even with the naked eye, we see a landscape dotted with countless craters, silent witnesses to the turbulent past of the solar system. These craters, like scars, adorn the lunar surface, reminding us of a time when space was a realm of chaos and destruction, when celestial bodies, like giant bullets, relentlessly bombarded the moon, Earth, and other planets. This period, known as the Late Heavy Bombardment, was a time when forming planets and their satellites were under constant assault from asteroids and comets. Imagine the moon as an ancient diary of the solar system, each page marked with the impressions and scars left by the relentless passage of time and cosmic cataclysms. Without an atmosphere to soften the blows or protect its surface, the moon bore the brunt of these destructive impacts directly. Each one left a deep, indelible mark, and over time, the moon became a sort of lunar archive, preserving evidence of a distant past. I often think about how each of these craters, whether it's a small dent or a giant crater like Copernicus, is a mark left by an ancient cosmic traveler. Earth, too, experienced similar cataclysms, but its surface has been altered over time by winds, rains, and tectonic processes. The moon, lacking these processes, has preserved its wounds unchanged, becoming a kind of chronicle where every mark is a message from the past, helping us understand how merciless the forces that shaped our solar system were. Sometimes, it seems to me that the moon is a cosmic museum, where every dent and every crater is an exhibit telling the story of billions of years ago. And each time I look at its surface, I can't help but marvel at its resilience and how it bears the traces of ancient bombardment, allowing us to peer into the distant past and better understand not only its history, but the history of our entire planetary system. The exploration of the moon began long before humans took their first steps on its dusty surface. The first satellites sent into lunar orbit started transmitting images of its mysterious surface, allowing scientists to create maps and identify potential landing sites for future missions. These were humanity's first cautious steps towards studying our closest cosmic neighbor. However, the true revolution in our understanding of the moon came in 1969, when the Apollo 11 mission successfully landed astronauts on its surface for the first time. It was a moment when the entire world held its breath, watching as humans conquered a new celestial body. In those years, the moon seemed unreachable, as if it existed on the boundary between the possible and the fantastical. But the Apollo 11 mission proved that even the boldest dreams can become reality if we put in enough effort. I often reflect on those historic moments when Neil Armstrong uttered his famous words, "That's one small step for man, one giant leap for mankind." These words still resonate in our hearts as a symbol that the pursuit of knowledge and exploration knows no bounds. The lunar missions not only demonstrated humanity's incredible technological achievements, but also provided us with unique samples of lunar soil and rocks that the astronauts brought back to Earth. I remember the first time I saw these samples in our laboratory. It was like touching an ancient artifact that held billions of years of history. These tiny particles of the lunar surface offered us a unique opportunity to peer into the distant past of our solar system. The study of these samples allowed scientists to determine the age of the moon, its chemical composition, and even reconstruct the history of its formation. Each examination of these lunar rocks was like turning a new page in a cosmic book, revealing the secrets of not only the moon's formation, but also that of the entire solar system. The lunar missions confirmed the giant impact hypothesis, which suggests that the moon was formed as a result of a colossal cosmic collision with Theia, but they also raised new questions about the origins of Earth and its satellite. The moon has become more than just an object to study. It has become a window into the past through which we can observe the processes that shaped our planet and its closest neighbors. And every time we send new missions to the moon, we uncover more of its secrets, delving deeper into our understanding of the forces that shaped our world. Modern space agencies like NASA, ESA, and Roscosmos, along with private companies like SpaceX, view the moon not just as an object for study, but as a key element in their plans for further space exploration. Imagine this. The moon, which has been our eternal companion for billions of years, could now become the foundation for ambitious space missions. A permanent base on the moon could serve as a launch pad for missions to Mars and even beyond, bringing humanity significantly closer to realizing the dream of interplanetary travel. But the moon is not just a stepping stone for space expeditions. Its resources, such as water ice found in polar craters, could play a crucial role in sustaining life and supporting future colonies. I often think about how the moon, which for billions of years has been merely a silent witness to cosmic events, could now become an active participant in a new era of human space exploration. In one of my meetings with colleagues, we discussed the possibility that within a few decades the moon could host not just research stations, but real cities where people would live and work, pushing the boundaries of our presence in space further and further. Today, the moon is not just a page from history, it is a future that we are only beginning to realize and design. The moon is our first step toward the stars, our cosmic bridgehead that could lead us to great discoveries and new horizons. And who knows, perhaps our descendants will speak of the moon as the place where the great era of space exploration began, where each new mission brought not only knowledge, but also opened doors to new worlds. In the future, the moon might become not only a symbol of humanity's first steps into space, but also the place where our truly interplanetary future begins. With each new mission and every new discovery, we will be closer to making the moon not just a celestial body in the night sky, but a real hung where a new chapter in the history of humanity will begin. When I first observed the lunar seas through a telescope, I was struck by their dark and mysterious appearance. These vast areas on the moon's surface seem to hold ancient secrets, locked in stone. Imagine this: when the moon was still young, its surface erupted with such force that entire regions were engulfed by giant lava lakes. This lava, flowing across the lunar surface, filled the lowlands created by asteroid impacts and, gradually cooling, transformed into the dark basalt plains that we now call lunar seas. What is particularly remarkable is that these seas, despite their name, contain not a drop of water. They received their names from early astronomers who, observing the moon through telescopes, saw these dark spots and mistakenly thinking they were actual seas or oceans, named them seas. Today, we know that these are nothing more than solidified basalt lava that filled giant craters formed by ancient asteroid collisions. These seas are like frozen imprints of the dramatic events that shaped the moon's modern appearance. Every time I look at the lunar seas, I am filled with a sense of awe, how this ancient lava, long since solidified, has preserved the history of the early moon. Each time we study lunar basalts, it is as if we are peering into the past, into an era when the moon was still young and active, when its surface underwent violent changes due to powerful volcanic processes. And although today the moon seems like a cold and motionless world, its seas are silent witnesses to those turbulent times when its surface teemed with activity, even if only in the form of molten lava. The lunar seas remind us of how important it is to continue exploring and studying our satellite. Every rock, every formation, every landscape on the moon holds a piece of history that can shed light not only on the evolution of the moon itself, but also help us better understand our own planet and its place in this vast and enigmatic cosmos. In contrast to the smooth and dark lunar seas, the highlands of the moon are bright, porous regions that rise above the basalt plains. These areas cover much of the moon's surface and are the oldest regions of our satellite. The age of the lunar highlands is estimated to be over 4 billion years, making them silent witnesses to the earliest stages of our solar system's formation. When I think of the lunar highlands, I imagine an ancient fortress, steadfastly guarding the secrets of the past. These highlands are composed mainly of anorthositic rocks, which contain the light-colored mineral plagioclase, giving them their characteristic bright hue. This light color can even be seen from Earth. One only needs to look at the moon through a telescope. These bright areas seem to illuminate the lunar surface, reminding us of its ancient origins and rich history. The surface of the lunar highlands is extremely uneven and is dotted with numerous craters formed by billions of years of impacts from asteroids and meteoroids. These craters vary in size, from small pits to massive structures like the Tycho crater, which spans about 86 kilometers in diameter. The Tycho crater, with its impressive rays radiating from the center, has always struck me with its grandeur. Every time I look at it, I can't help but marvel at the colossal forces that created this striking landscape. What's particularly fascinating is that the highlands preserve evidence of the moon's ancient geological history. These regions represent remnants of the original crust that formed when the moon was still young and covered by a magma ocean. The image of a vast, boiling ocean of magma stretching across the surface of the young moon always fills me with awe. Imagine this turbulent, seething mass gradually cooling and crystallizing to form a solid crust, the very crust that, over time, would become the lunar highlands. The lunar highlands are like an ancient archive, holding pages of history that humanity is only beginning to decipher. Every crater, every mountain range tells us about events that occurred billions of years ago, when the moon was still young and geologically active. When I look at these ancient, cratered landscapes, I am filled with admiration. Nature has created such a remarkable and intricate world, which, despite its apparent stillness, continues to be a source of knowledge and inspiration for all of us. The seas and highlands of the moon do not exist in isolation. They are intricately intertwined, creating a complex landscape, like a canvas painted by nature itself. In some areas, lava flows from the lunar seas have cut through the highlands, filling the lowlands and forming unique boundaries between these two types of terrain. These boundaries, like the brushstrokes of a master artist, are often uneven and jagged, reflecting the moon's turbulent past, full of collisions and volcanic activity. When I observe these boundaries through a telescope, it feels as though I am witnessing the traces of an ancient time when the moon was still forming, and its surface was a battleground of geological forces. The interaction between the seas and highlands is also evident in the distribution of craters. If you look closely at the highlands, you can see that they are dotted with numerous old craters, some of which are so ancient that their edges have almost completely worn away with time. These craters are witnesses to eras when the moon was subjected to intense bombardment by meteorites and asteroids, leaving deep marks on its surface. The lunar seas, on the other hand, contain both old and new craters, indicating that these smooth plains formed after the highlands. When lava flows flooded the surface, they filled old craters, creating relatively flat areas, but new impacts from cosmic objects continued to leave their marks on this new surface. These interactions between seas and highlands demonstrate how dynamically the moon's surface has evolved over billions of years. In one place, a lava flow might break through ancient mountain ranges. In another, it could fill a massive crater, creating a new sea region. This process, like a dialogue between different epochs, shows that the moon is a living museum where the changes that have occurred throughout its long history can be traced. When I look at the moon and observe these interconnections, I can't help but reflect on how closely the past and present are intertwined. The seas and highlands of the moon are not just different landscapes, they are parts of a unified history that continues to unfold before our eyes. The interaction of these regions, their unity and diversity, makes the moon such a captivating object of study and inspiration. Every crater, every lava plain, every mountain range tells a story full of drama and grandeur, reminding us of the importance of these celestial chronicles. The moon has always been perceived as a barren, lifeless world, devoid of the resources we consider essential, such as water. However, in 2009, this perception was radically changed thanks to NASA's L-Cross Lunar Crater Observation and Sensing satellite mission. Scientists made a remarkable discovery. Significant amounts of water in the form of ice were found in the polar regions of the moon, hidden in the coldest and darkest corners of its surface. Imagine this: water, possibly delivered by comets or asteroids billions of years ago, has been trapped in deep craters where it has remained unchanged for an immense period of time. These dark and cold craters are true time capsules, carefully preserving water since the solar system was in its infancy. The discovery was made possible through the use of advanced technologies such as radars and spectrometers, which allowed scientists to analyze the light reflected from the moon and detect characteristic signals indicating the presence of water ice. When I think about the fact that the moon, this dry and dusty world, is a keeper of ancient water, I am filled with a sense of awe at how wondrous and unpredictable space is. This discovery has overturned our understanding of the moon and opened new horizons for future space exploration. Water, so commonplace on Earth, could become the key to the survival of future lunar colonies, providing them with resources for drinking, growing food, and producing rocket fuel. Lunar ice in polar craters is not just a finding, it is a symbol of how space continually surprises us, challenging our notions of what is possible and what is real. These icy reservoirs could become the foundation for creating self-sustaining settlements on the moon, bringing humanity one step closer to fully embracing space exploration. The moon, once seen as a dry and barren world, now appears to us as a treasure trove of resources, ready to help us extend the boundaries of our presence in the solar system. The presence of water on the moon is not just a scientific sensation, it is a crucial factor that could make long-term human habitation on its surface possible. Water, which we take for granted on Earth, becomes one of the most valuable resources when it comes to space missions. On the moon, water takes on a significance that goes far beyond its usual uses. Through the process of electrolysis, water can be broken down into oxygen for breathing and hydrogen, which can be used to produce rocket fuel. This process allows us to literally split water into its elemental components and use them to sustain life and enable movement in space. Water on the moon becomes more than just a liquid. It is the key to creating sustainable infrastructure for space exploration. Imagine a future where lunar bases regularly replenish their water supplies directly on site. This would dramatically change the logistics of space missions. Water extracted on the moon would eliminate the need to transport vast amounts of it from Earth, one of the most complex and costly challenges in space travel. The availability of water on the moon would not only simplify our missions, but also make them significantly more efficient and cost-effective. Could humanity settle on the moon? With the presence of water, absolutely. We could establish and maintain greenhouses where plants would grow, supporting a closed ecosystem that provides colonists with oxygen and food. These possibilities open the door to the next stage of space exploration. The moon, which has always seemed barren and hostile, suddenly becomes a place where not only survival is possible, but also the creation of a stable base for further exploration. Water on the moon becomes more than just a resource, it is the foundation for a sustainable future in space. With it, we can not only sustain life, but also venture further to new worlds. Using the moon as a launch pad for interplanetary missions, water is the key to our future in space, and its presence on the moon opens up incredible opportunities for expanding the boundaries of our presence in the solar system. Developing and implementing the technologies needed to extract and use water on the moon is an incredibly complex and ambitious task. The ice discovered in the lunar polar craters lies deep beneath the surface in some of the coldest and most inaccessible regions. These areas, where sunlight never reaches, are extreme zones with temperatures dropping to 250 degrees Fahrenheit 157 degrees Celsius. To access this ice, innovative equipment and methods will be required, capable of not only drilling into the lunar surface but also extracting ice in such harsh conditions. However, despite these technological challenges, the future of using lunar water looks very promising. Programs like NASA's Artemis aim to return humans to the moon and establish a sustainable base on its surface. This program envisions not just short-term missions, but long-term human presence on the moon, which will inevitably require solutions for utilizing local resources, including water. Hydrogen and oxygen extracted from water could be used both to sustain life and to produce rocket fuel, paving the way for further missions from the moon to more distant parts of the solar system. Moreover, the development of technologies for working on the moon could become a catalyst for creating new technologies on Earth. Innovations needed to overcome lunar challenges might find applications in other extreme environments on our planet, opening new horizons for research and industry. Thus, despite significant technological challenges, the prospects of using water on the moon present humanity with enormous opportunities. These efforts will not only bring us closer to establishing permanent bases on the moon, but will also be a crucial step toward exploring deep space. The moon, as a key stage in the development of space infrastructure, could become a starting point for exploring and colonizing more distant planets and moons, turning the dream of interplanetary travel into a reality. Every obstacle we overcome in the process of lunar exploration will bring us closer to new frontiers in space exploration. The moon, which we are on the verge of returning to, is becoming not just a destination but a tool for moving further into the depths of the solar system, opening up new worlds and possibilities for humanity. The moon, our closest celestial neighbor, could become the launching point for more ambitious missions aimed at exploring deep space. If humanity learns to extract and efficiently use water on the moon, entirely new horizons will open for space exploration. The water locked in lunar craters could become a crucial resource for creating refueling stations for spacecraft heading to Mars and even beyond. Imagine this. Hydrogen derived from lunar water is used to refuel spacecraft, significantly reducing costs and mitigating the risks associated with interplanetary travel. This process is of immense importance because transporting fuel from Earth requires vast resources and is one of the primary challenges in space missions. The ability to produce fuel directly on the moon would revolutionize the approach to interplanetary journeys. The moon could become a kind of way station, where ships could refuel before embarking on their journeys to the far reaches of the solar system. This is not just a dream, but an increasingly attainable scenario, thanks to the technologies being developed in current and future space programs. Moreover, the presence of water on the moon makes it an extremely attractive target, not only for governmental space agencies like NASA, ESA, and Roscosmos, but also for private companies that are increasingly becoming active players in the space race. Private corporations like SpaceX and Blue Origin are already considering the possibility of establishing lunar bases and extracting resources. The potential for commercial exploitation of lunar water resources could form the foundation of a burgeoning lunar economy, encompassing the extraction and production of fuel, as well as the creation of lunar settlements. Ultimately, the moon could become a critical stage in a chain of missions leading to deep space exploration. Mastering the technologies needed to extract and utilize lunar water will bring us closer to the point where interplanetary missions become routine, and the farthest corners of the solar system are within reach for exploration and perhaps even colonization. Water on the moon is the key to our spacefaring future, and harnessing this resource will be a significant step toward the stars. The discovery of water on the moon was a turning point in our cosmic odyssey. It is not just a scientific breakthrough, it is the key to understanding humanity's future in space. Lunar water could become a source of life, fuel, and new opportunities for exploring the solar system. As Neil deGrasse Tyson might say, when we look at the moon today, we see not just Earth's satellite, but a repository of possibilities that could lead us to the stars. The moon, being the closest celestial body to Earth, has long attracted the attention of scientists and explorers. Since the first successful space launches in the mid-20th century, the moon has been the target of numerous missions aimed at studying its surface, composition, and resources. These missions, conducted by various space agencies, have significantly contributed to our understanding of the moon and laid the groundwork for future lunar expeditions and potential colonization. One of the most iconic phases in lunar exploration was NASA's Apollo program. Between 1969 and 1972, 6 missions successfully landed astronauts on the moon, where they conducted various scientific experiments, collected lunar soil and rock samples, and installed scientific instruments for long-term studies. The Apollo 11 mission in 1969, during which Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface, remains one of humanity's greatest achievements. These first steps on the moon were not just a symbol of technological progress, but the beginning of a new era in space exploration. The Apollo program not only confirmed the feasibility of landing on the moon, but also provided a wealth of scientific data. Hundreds of kilograms of lunar soil were collected, and these samples continue to be studied by scientists worldwide. These materials formed the basis for theories about the moon's origin, geological history, and the processes occurring on its surface. Research conducted during the Apollo program helped confirm the giant impact hypothesis, which suggests that the moon was formed as a result of a collision between a young Earth and a planetary body the size of Mars. This hypothesis has become a cornerstone in understanding the evolution of Earth and its satellite. In addition, the Apollo missions initiated the exploration of lunar resources, including mineral and water reserves, which could potentially make the moon an important source of materials for future space missions. After the conclusion of the Apollo program, lunar exploration continued, but at a less active level. In recent decades, interest in the moon has surged once again. Programs such as China's Chang'e, India's Chandrayaan, and NASA's Artemis are focused on returning humans to the moon and further exploring its surface. These new missions are aimed not only at short-term expeditions, but also at establishing permanent bases that could serve as launch pads for deep space exploration. With advancements in technology and growing interest in space exploration, the moon is once again in the spotlight. This new wave of exploration offers humanity the opportunity to create self-sustaining lunar bases, extract resources, and conduct scientific research that could help prepare for future missions to Mars and beyond. The moon, which began its history as the target of the first space missions, is now becoming a key element in the strategy for space exploration. Every new mission brings us closer to the day when the moon will not just be a celestial body, but our cosmic home, from which a new chapter in human history will begin. The conclusion of the Apollo program marked a significant milestone in lunar exploration, but it was by no means the end of our ambitions. Decades later, the moon is once again at the center of global attention. The discovery of water on its surface has opened up new possibilities for space missions that could make the creation of permanent lunar bases a reality. Programs like NASA's Artemis aim not only to return humans to the moon, but also to create the conditions for long-term habitation, using local resources such as water to support life and produce rocket fuel. The moon, once merely an object of dreams and romantic views of the night sky, is now becoming the tangible goal for scientific research and space exploration. Its role as a repository of possibilities is only growing, and in the future it may become a crucial stage on the path to the stars. After the conclusion of the Apollo program, the focus of scientists and engineers shifted toward detailed mapping and studying the moon from orbit. One of the notable missions in this effort was Clementine 1994, developed in collaboration between NASA and the US Department of Defense. This mission utilized a range of advanced sensors to create detailed maps of the lunar surface and investigate the composition of lunar minerals. When I think of Clementine, it reminds me of ancient maps of uncharted lands that gradually filled with details as they were explored. But this time, the cartographers worked in space, uncovering the secrets not of Earth's surface, but of the moon's. The Clementine mission was particularly significant because it was the first to indicate the presence of water ice in the moon's polar regions. Imagine the astonishment of scientists when they received data suggesting that in the eternal shadows of lunar craters where temperatures dropped to 250 degrees Fahrenheit, ice might be hiding. This discovery was akin to finding an ancient oasis in a desert that no one knew existed. Water on the moon is not just a discovery, it is a key to the possibility of creating lunar bases capable of sustaining life. Another important milestone in lunar exploration was the Lunar Prospector mission 1998. This mission also confirmed the presence of water ice in the permanently shadowed craters at the moon's poles. I remember one of my colleagues excitedly discussing how the data from Lunar Prospector finally provided solid evidence that water on the moon does indeed exist and can be utilized. It was like discovering a precious treasure hidden in the darkest and coldest part of the moon. Lunar Prospector also played a crucial role in studying the distribution of chemical elements on the moon's surface and identifying anomalies in its gravitational field. These data confirmed the theory that the moon has an iron-rich core. This discovery reminds me of how we are gradually unveiling the moon's inner secrets, as if peeling away layers to reach the very heart of our celestial neighbor. When I look at the data collected by these orbital missions, I can't help but marvel at how far we have come since the days when scientists relied solely on telescopes and visual observations. We are no longer just observing the moon from Earth. We are sending robots and orbiters that map every square meter of its surface, gathering information that may one day lead us even further into the depths of the solar system. These missions, Clementine and Lunar Prospector, were important steps toward a deeper understanding of the moon and preparation for its future exploration. They showed us that the moon is not just a lifeless celestial body, but a place full of resources and mysteries yet to be uncovered. And every new orbital probe sent to the moon brings us closer to the day when the moon will become a true stepping stone for our journey to the stars. The China National Space Administration (CNSA) has become one of the leading players in lunar exploration in recent years. China's Chang'e program began in 2007 with the launch of the Chang'e-1 orbiter, which conducted detailed mapping of the lunar surface. To me, this mission was reminiscent of the first steps toward creating detailed maps of unexplored lands. The maps created by Chang'e-1 became the foundation for future lunar expeditions, laying the groundwork for everything that followed. Subsequent missions, such as Chang'e-2 2010, not only continued the work of mapping, but also conducted surveys of potential landing sites for future missions. This was a strategic move that demonstrated China's intent not just to study the moon, but to actively work toward its exploration. When I first learned about the Chang'e-2 mission, I thought about how each new satellite and spacecraft brings us closer to returning to the moon, this time with new understanding and more ambitious goals. In 2013, China achieved a significant milestone with the successful landing of the Chang'e-3 mission, which delivered the Yutu rover to the lunar surface. For me, this event was a true triumph of China's space program. It was the first successful landing on the moon since 1976 and yielded significant scientific results. Yutu studied the composition of lunar soil and investigated the radiation environment on the lunar surface. I recall how my colleagues discussed the success of this mission, comparing it to the era of the first lunar missions. For many of us, it was proof that the moon was once again becoming a stage for international research. Perhaps the greatest surprise came with the Chang'e-4 mission in 2019, when China became the first nation in history to achieve a soft landing on the far side of the moon. I remember how news of the landing literally electrified the scientific community. This was not just a technical achievement, but the opening of a new frontier in lunar exploration. The far side of the moon had long remained a mystery, as no spacecraft had ever successfully landed there. The Chang'e-4 mission included not only a lander, but also the Yutu-2 rover, which continues to transmit data about the geology and composition of the lunar surface from the far side. These data provide us with a unique opportunity to understand how the moon formed and what other surprises it may hold. When I think of China's lunar missions, they seem to exemplify how quickly and effectively one can achieve success in space exploration with clear vision and determination. China has not only caught up with other spacefaring nations, but has also opened new chapters in the history of lunar research. These missions have shown that the moon remains a vital object of study, and that we are only beginning to uncover its secrets. And who knows, perhaps China will be the first nation to send humans to the far side of the moon, opening yet another chapter on the path to the stars. The SMART 1 mission marked a significant milestone in lunar exploration for the European Space Agency (ESA). This spacecraft was equipped with an innovative ion propulsion system, allowing it to gradually but surely reach lunar orbit. I recall a colleague marveling at the dance of ions that enabled the spacecraft to reach the moon using just a few hundred kilograms of fuel. It was a reminder of how far technology has come since the days of the heavy rocket launches of the past. SMART 1 conducted mapping of the moon in ultraviolet, infrared, and X-ray wavelengths, providing scientists with new data on the lunar surface's composition. I often think about how this small but powerful spacecraft allowed us to see the moon in a new light, revealing details about its chemical makeup and geological features. Moreover, the SMART 1 mission demonstrated the potential of ion engines for interplanetary travel, a significant advancement in space technology. However, interest in the moon is not limited to government space agencies. In recent years, there has been a notable increase in interest from private companies and international consortia. A prominent example is the Google Lunar X Prize, an international competition that truly energized the space community. The idea behind this competition was to encourage private teams to create robots capable of making a soft landing on the moon and transmitting video footage from its surface. Although no team succeeded in winning the grand prize, the competition served as a catalyst for developing new technologies and approaches to lunar exploration. I remember discussing this project with colleagues, and we all agreed that even failures can lead to important discoveries. Thanks to this competition, numerous startups and private companies made significant strides in developing new technologies that could be used in future missions. International efforts in lunar exploration have also led to increased collaboration between different countries and organizations. For example, joint missions and research between ESA, NASA, and other space agencies demonstrate how pooling resources and knowledge can accelerate the exploration of the moon. This collaboration includes not only the exchange of scientific data, but also the development of joint missions, such as the upcoming Artemis lunar expeditions, where ESA plays a significant role. Ultimately, European and international efforts in lunar exploration highlight the importance of global cooperation. The moon is not just an object of study, it is becoming a place where humanity unites its efforts to open new horizons and prepare for future interplanetary missions. While we face serious challenges, such as utilizing lunar resources and establishing sustainable bases, international and private initiatives continue to pave the way toward this bright future. When I think about the future of lunar missions, I am filled with a sense of excitement similar to what I felt when I first looked at the moon through a telescope as a child. Back then, the moon seemed distant and mysterious, an unreachable dream. But now, as we stand on the brink of a new era of exploration, that childlike wonder returns, only now it is bolstered by a deep understanding of the incredible discoveries that await us. Modern and upcoming missions continue to expand our understanding of the moon, preparing humanity for a new phase of space exploration. NASA is gearing up for a new wave of lunar research under the Artemis program, which aims to return humans to the moon by the mid-2020s. I recall a veteran of the Apollo program saying during a discussion at a scientific conference, "We will return not as guests, but as hosts." These words made me reflect on how far our technology and ambitions have come since those early days. The Artemis program is more than just a return to the moon. It is a step toward establishing a permanent lunar base that will serve not only as a scientific hub, but also as a testing ground for technologies necessary for missions to Mars. Imagine laboratories, power stations, and habitats for astronauts being constructed on the lunar surface. The moon, once perceived as a barren and lifeless world, could transform into a bustling center for space research and preparation for interplanetary missions. Reflecting on my participation in discussions about the Artemis program, I am particularly struck by the idea of utilizing lunar resources to sustain life on the base. The water discovered in the polar craters could be used to produce oxygen and hydrogen, essential for breathing and rocket fuel production. This discovery, like a drop of water in the desert, opens up new horizons for us. The moon is no longer just a target, it is becoming the key to the further exploration of the solar system. China and Russia are also making significant strides in this space race. They have announced plans for a joint program aimed at establishing an international lunar research station by the 2030s. I remember hearing a Chinese colleague say during an international meeting discussing this program, "The moon is not a battlefield, but a platform for cooperation." These words underscore the idea that the moon could become a place where humanity unites its efforts to create a new chapter in the history of space exploration. This station could be a crucial step toward establishing a permanent human presence on the moon. I often envision a future where, in a few decades, the lunar surface will host not just laboratories, but entire settlements where new technologies will be born and developed. The moon could become the launch pad for missions to Mars and beyond. Every time I look at the moon, I recall someone once telling me, "The moon is a mirror of our aspirations." Indeed, the more we learn about it, the closer we get to realizing our dreams of conquering space. The future of lunar missions is not just about new scientific discoveries. It is the beginning of a new era in human history where the moon will become our first step toward the stars. When I think about the significance of the moon in the context of space exploration, I always return to the idea that the moon is not just our nearest celestial neighbor, but a true bridge to our cosmic future. From the first human steps on its surface to plans for building a permanent base, the moon has become an essential testing ground for research and exploration that may ultimately lead us to the stars. These steps we are taking on the moon are crucial not only from a scientific perspective, but also for our future in space. The moon is the first place where we can begin to live and work in conditions similar to those of interplanetary missions. It offers us the opportunity to learn and adapt, developing the technologies and processes that will one day help us venture further, to Mars, to asteroids, and perhaps even to other star systems. NASA's Artemis program represents the first step toward returning humans to the moon, embodying not only the desire to replicate the achievements of 1969, but also the ambition to achieve something greater, something significant for the future of humanity. An engineer I once spoke with said, "We're not just going back to the moon, we're building a home there." These words perfectly capture the essence of the mission. Goal is not just to leave footprints in the lunar dust, but to establish infrastructure that will ensure long-term and sustainable human presence on the moon. The Artemis program is focused on creating a permanent infrastructure that will allow astronauts not just to visit the moon, but to stay there for extended periods. As part of this program, plans are in place to establish the first lunar base, which will serve as a center for scientific research and commercial projects. This base will not only facilitate the study of the moon, but also serve as a testing ground for technologies essential for deep space exploration. The lunar base will become a kind of laboratory on the edge of space, where new methods of construction, life support, and resource extraction will be tested, which will one day help us on Mars and beyond. A key feature of the Artemis program is its multi-phased approach. Initially, robotic missions will be sent to the moon to conduct detailed surface studies. This is not just reconnaissance, but a thorough analysis of the most suitable sites for building the base. At a conference, scientists said, "We're studying the moon not only through the eyes of robots, but also with the view of seeing it as a home." These words emphasize NASA's serious approach to selecting a location for the future base. Following this, the Gateway module will be placed in lunar orbit, a sort of spaceport that will serve as a staging area for astronauts heading to the surface. Gateway will become an essential part of the infrastructure for interplanetary missions, including missions to Mars. This orbital platform symbolizes yet another step toward making space travel more routine, reliable, and ultimately accessible. All these missions, past, present, and future, underscore the importance of the moon as a key object for exploration and a stepping stone to a greater understanding of our planetary system. The moon remains a crucial testing ground for new technologies, methods, and scientific theories that will ultimately help us not only better understand it, but also prepare for the exploration of deep space. With each new discovery and mission, the moon brings us closer to realizing humanity's boldest dream, to become an interplanetary species. The future of lunar exploration truly promises to be one of the most exciting chapters in the history of space exploration. When we think of the moon, we often imagine it as our closest cosmic neighbor, but in reality, it may become the launching point for our ambitions that extend far beyond Earth's orbit. In the coming decades, the moon will not just be an object of study, but a platform for experiments, innovations, and possibly even interplanetary travel. When I first heard about the plans to establish permanent bases on the moon, my imagination immediately conjured up images of a distant future where people live and work under domes built on the surface of our satellite. But what makes these plans particularly exciting is the realization that this future could arrive much sooner than we thought. The moon, which has long been a target for short-term missions, is now being considered as a place where humans can live and work on a permanent basis. The Artemis mission opens new horizons for humanity, showing that the moon can become our second home, a launching pad for further exploration and the colonization of other worlds. One of the primary goals of future lunar exploration is the establishment of permanent bases on the moon's surface. These bases will likely be located in the polar regions, where water ice deposits have been discovered. When I think about lunar bases, I recall a conversation with a colleague who once said, "The moon is our cosmic treasure trove. If we learn to utilize its resources, it will provide us with everything we need." These words capture the essence of the plans to use local resources such as lunar ice to obtain water, oxygen, and fuel. This idea, like discovering a life-giving oasis in a desert, opens up new possibilities for sustainable habitation on the moon. Life on a lunar base will be fraught with numerous challenges. Extreme temperatures ranging from 173 degrees C at night to Pompeius 127 degrees C during the day, high radiation levels, and the absence of an atmosphere create conditions where every detail matters. When I envision these conditions, I am reminded of stories from polar explorers who survived in the harshest environments on Earth. But while Earth provides air and water, on the Moon, every drop of water and every breath will have to be supplied through technology. These extreme conditions necessitate the creation of reliable life support systems and protective measures. Recalling my conversations with engineers involved in developing such systems, I often heard the phrase, "Every kilowatt of energy and every gram of mass counts." This extreme conservation of resources is akin to creating an autonomous station in the middle of the ocean, where the smallest mistake could be fatal. What is particularly inspiring is that the development of such technologies could not only make life on the Moon possible, but also prepare us for living on Mars and other planets. The Moon will serve as a testing ground where technologies for survival in extreme conditions will be honed. If we can establish stable and safe bases on the Moon, it will be proof that humanity is ready to colonize other planets. I recall discussions with colleagues about what a lunar base might look like. Some spoke of underground shelters protected from radiation, while others envisioned inflatable modules that would be deployed on the surface. Regardless of form and construction, these bases will symbolize a new era in space exploration. They will demonstrate that humanity can adapt and survive in the harshest conditions using advanced technologies and innovative approaches. The Moon, once perceived as a cold and barren world, is now becoming a place where a new spacefaring civilization could be born. The creation of permanent bases on its surface is not just science fiction, it is a real step toward making the Moon our second home, and, perhaps, a launching pad for further exploration of the solar system. When I think about this, I realize that the Moon is not just an object of study, but a key to our cosmic future. Imagining the possibility of creating lunar colonies brings to mind images from the science fiction films of my childhood, where people live in domes on the Moon's surface, work in laboratories, and build ships for journeys to distant planets. But today, this is no longer just fantasy, but a very real prospect toward which humanity is steadily moving. With each step that brings us closer to this goal, we not only push the boundaries of what is possible, but also write a new chapter in the history of our species, where the Moon will become not just our nearest cosmic neighbor, but our new home and the starting point for the exploration and colonization of other worlds. The establishment of permanent bases on the Moon is only the beginning. The next logical step is the creation of lunar colonies. The idea of colonizing the Moon may seem ambitious, but it represents humanity's first practical attempt to settle beyond Earth. Lunar colonies could become more than just temporary shelters for scientists and engineers. They could evolve into true settlements where people live and work, pushing the boundaries of exploration every day. Imagine lunar colonies as scientific research stations where new technologies for space travel are developed and tested. I recall a conversation with a space engineer who compared future lunar colonies to polar stations on Earth. He said, "If we can live and work in Antarctica, where the cold and isolation resemble conditions on the Moon, then lunar colonies are just a matter of time. These stations will utilize lunar resources such as the ice deposits in the polar craters to produce water, oxygen, and even fuel. These are not just scientific experiments, but vital technologies that will allow us to survive and thrive beyond Earth." But lunar colonies are not only about scientific bases. I also envision commercial hubs where new businesses and industries related to space exploration will flourish. Remembering the words of an entrepreneur who spoke of space as the new frontier for business, I realized that the Moon could become a place where entire industries emerge, from mining resources to producing energy and materials essential for space travel. Such colonies could also serve as launch points for missions into deep space. Utilizing lunar resources to produce fuel will open up entirely new possibilities for space launches. Launching spacecraft from the Moon, where gravity is significantly weaker than on Earth, will be much easier and cheaper. This means that the Moon could become a sort of spaceport for missions to Mars, asteroids, and even the outer planets of the solar system. When I imagine this scenario, I recall discussions with scientists who see the Moon as a springboard to the stars. They spoke of how, if we can build and maintain lunar colonies, it will prove that we are ready to live beyond Earth and can expand our presence in the solar system. Lunar colonies will not just be a step forward, but a true leap into the future, where humanity can begin to explore new worlds. Thus, the creation of lunar colonies is not just a technical challenge, it is a crucial stage in transforming humanity into an interplanetary species. The Moon, once only an object of observation, is now becoming a key element in our quest for the stars. Every new mission, every step taken on the Moon brings us closer to the moment when we can say, we are an interplanetary species, and the Moon is our first home beyond Earth. When I think about the scientific research associated with the Moon, I envision not only space missions and laboratories, but also how we can use the Moon as a window into the past and future of our planet and the entire solar system. The Moon, this silent companion of Earth, holds within it stories of billions of years waiting to be uncovered and read. Lunar colonies are not just plans on paper. They are the next significant step in the evolution of humanity. They will become a symbol of our drive to explore and settle new worlds, expanding the boundaries of what is possible and advancing ever further into space. The Moon remains an object of immense scientific interest. Its surface, scarred by craters and seas of solidified lava, resembles an ancient scroll inscribed with the key moments of the solar system's formation. When I first heard about the idea of studying lunar rocks to understand the origin of Earth, it reminded me of finding fossils as a child and trying to imagine what the world looked like millions of years ago. The Moon is like a cosmic-scale fossil, preserving secrets that could shed light on how our planet and its nearest neighbors came into existence. Studying lunar rocks, exploring the Moon's internal structures, and searching for traces of ancient volcanic activity can provide new insights into how our planet developed. Reflecting on discussions about lunar missions, I recall a geologist saying, "Every rock on the Moon is a page from the Book of Early Earth." These words struck me deeply, as they underscore how important the study of the Moon is for understanding not only the Moon itself, but also our own world. The Moon can also serve as an ideal platform for astronomical observations. Imagine this. The absence of an atmosphere and the low gravity make the Moon a perfect location for installing powerful telescopes that could peer deeper into space than is possible from Earth. Hearing about such plans reminded me of the first time I looked through a telescope at the night sky. I was awestruck by seeing the Moon in detail, realizing that every glance through a telescope is a window into the vastness of space. But the Moon could open these windows even wider. Telescopes on the Moon could search for exoplanets, study distant galaxies, and observe cosmic objects beyond the reach of ground-based observatories. An astronomer once told me, the Moon is our launch pad for exploring the universe. Indeed, by setting up observatories on its surface, we could observe the cosmos with a precision and clarity unattainable on Earth due to atmospheric interference and light pollution. The Moon, which for billions of years was a silent companion, can become an active participant in our space research. Its surface could serve as a base for studying not only itself, but everything beyond it. I imagine scientists gathering in these lunar observatories, discussing new discoveries, and sharing what they have seen in the vast depths of space. This is not just scientific fantasy, but a real prospect, making the Moon a critical element in our quest to understand the universe. When we place telescopes on the Moon, it's as if we're setting up beacons that illuminate the path to the future of space exploration. The Moon, ancient and unchanging, opens doors to worlds we are just beginning to explore, and with each new discovery it becomes not just Earth's satellite, but our guide to the great unknown. As I reflect on the future of lunar research, it becomes clear that the Moon has long ceased to be merely a subject of scientific interest. It is viewed as a new frontier where science and business are beginning to intertwine. Just a few decades ago, such ideas seemed like something out of science fiction, but now they are becoming a reality that is shaping the future of space exploration. The Moon, as a scientific object, offers us incredible opportunities. It holds the keys to understanding the past of our solar system and perhaps its future. As a platform for astronomical observations, it can provide humanity with new knowledge about the distant corners of the universe. Science and business united on the surface of the Moon could create a new format of space economy, where research and commercial activities go hand in hand. The future of lunar exploration is intertwined not only with science, but also with the potential commercialization of the Moon. Today, private companies like SpaceX, Blue Origin, and others are actively considering the Moon as a potential market for their services and technologies. Reflecting on my conversations with colleagues in the space industry, I often heard them speak of the Moon not as a distant and unreachable object, but as a new frontier to be explored. The idea of commercial missions delivering cargo to the Moon, building lunar bases, and even mining resources is no longer just fantasy. These are ambitious plans that are beginning to take shape. Imagine a near future where private companies compete for contracts to deliver equipment and materials for constructing lunar bases. These bases will not just be scientific centers, but also hubs of production and trade, where new technologies for deep space exploration will be developed and tested. At a conference, I once heard a company representative say, "The moon is our launch pad. If we learn to operate here, the entire cosmos will be our next goal." These words deeply impressed me as they highlight how closely linked the commercialization of the moon is with the future of space expansion. The moon could become a source of rare and valuable materials such as helium-3, which could be used in advanced fusion technologies. Helium-3, which I first learned about during my early studies in cosmology, is an isotope that is extremely scarce on Earth but could play a crucial role in creating new energy sources. Imagine the moon, this cold and lifeless world, becoming an energy reservoir for the entire planet. The economic potential of the moon is attracting attention from both private companies and governments, leading to discussions of international treaties and agreements on the use of lunar resources. One of my colleagues with whom I discussed these prospects once said, "The moon is not just a chunk of rock, it's a new world that could change our entire economy." His words reminded me of how human history has always been driven by the discovery of new resources, from gold to oil, and now perhaps the moon will become the next chapter in this story. We are on the brink of creating a new space economy with the moon at its center. The commercialization of the moon also raises important questions about the rights to use its resources. Discussions are already underway about possible international agreements that will regulate the extraction and distribution of lunar resources. This process reminds me of how nations once negotiated the rights to marine resources, only now the stakes involve space itself. Ultimately, the commercialization of the moon is not just another chapter in the space race. It is an opportunity for humanity to reach a new level of development, where space becomes not just a place for exploration, but also a place for living and working. The moon, which has always been a symbol of dreams and ambitions, is now becoming the center of new economic and technological opportunities that could change our world. When I think of the moon as the key to humanity's space future, I recall my first visit to an observatory, where I first looked at the moon through a telescope. I was captivated by its cratered surface, and at that moment it seemed so distant and unreachable. But much has changed since then. The moon, which once was merely the object of our dreams and romantic views of the night sky, has now become the first step on the path to space exploration. The moon opens up vast opportunities, and each new generation of space explorers and entrepreneurs brings us closer to the moment when it will become not just a subject of study, but a vital element in a new space-based economy. The surface features of the moon, such as its seas and highlands, are more than just geological structures. They are the pages of an ancient book that chronicles the history of our natural satellite's formation and evolution. Every crater, every elevation on the moon is a testament to its past, like fingerprints left by cosmic processes on its surface. Studying these features helps scientists understand not only the processes that occurred on the moon, but also those in the broader solar system. The moon, with its contrasting landscapes, remains a window into the past, revealing the mysteries of ancient catastrophes and geological processes that shaped it and ultimately our Earth. The contrast between the smooth, dark Maria and the bright, cratered highlands allow us to peer into the depths of time and see how the moon became what we know today. It is a kind of archive, preserving knowledge about the early solar system and its evolution, knowledge we are only beginning to uncover. One of the most intriguing and exciting discoveries in recent years has been the detection of water on the moon's surface. Water, a simple yet vital element that we take for granted on Earth, has proven to be a significant find on our cosmic neighbor. I remember the first time I heard about this discovery. It turned our understanding of the moon upside down and opened new horizons for future space exploration. The discovery of water on the moon was a true sensation. Suddenly, it became clear that our natural satellite, long considered lifeless and dry, might contain water reserves in its polar craters. This finding not only expands our knowledge of the moon, but also changes the approach to planning future missions. We can now envision bases on the moon where water extracted from lunar ice is used for drinking, growing plants, and producing fuel for further space travel. The moon, which we long perceived as a static and unchanging object, has once again become the focus of attention due to its hidden treasures. The contrasts on its surface, whether in geological structures or the presence of water, open up new possibilities, and give us the key to understanding not only its history, but also how we can use this knowledge to explore space. The Moon remains not just a satellite of Earth, but a crucial link in the chain of space exploration, and its study continues to inspire new discoveries that may change our understanding of the universe. The future of lunar exploration represents a unique opportunity for humanity to take its first steps beyond its home planet and begin the exploration of the solar system. The Moon, this ancient companion of Earth, could become our testing ground for developing technologies that will one day allow us to colonize Mars and venture further into the cosmos. When I contemplate how the Moon could become the launching point for future space expeditions, I recall the words of the scientist I discussed lunar mission prospects with. He said, "The Moon is our space gym. If we learn to live and work there, the rest of space will become much closer." These words moved me deeply because they emphasize how important the Moon is for our future. It is not just the closest celestial object. It is our first frontier in the grand cosmic journey. Every new step on the Moon is a step toward making space a part of our everyday lives. Imagine lunar bases where scientists and engineers work on developing technologies for interplanetary travel, telescopes installed on the Moon's surface, studying distant galaxies, commercial missions delivering valuable resources back to Earth. The Moon is becoming not just a place for research, but an integral part of human civilization. When I spoke with one of the engineers involved in developing lunar projects, he shared an anecdote that particularly stuck with me. "If you think Earth is our final destination, you're still in the starting corridor." This image, Earth as a launch pad for something greater, perfectly illustrates our attitude toward space. The Moon is the first station on this great journey. Moreover, the Moon could be the key to unlocking endless possibilities and opportunities. Its resources, unique conditions, and proximity to Earth make the Moon an ideal starting point for exploring the solar system. I often imagine how, in a few decades, spacecraft will regularly depart from lunar bases to other planets, just as sailors once set out from European ports in search of new lands. Ultimately, the Moon symbolizes our first step into space, but it is only the beginning. As my old mentor would say, the Moon is the key to the stars, and while it opens the door, it is just the first of many we will need to unlock. The Moon is not just a destination, it is the start of a new chapter in human history, a chapter that could lead us to incredible discoveries and new worlds. And every step we take on the Moon brings us closer to this bright spacefaring future. Don't forget to subscribe to the channel so you don't miss new videos. Click the subscribe button and be sure to hit the bell to receive notifications of fresh episodes. Support us and you'll always be in the loop on the most exciting events.